Here are the notes for section 5.5. We're going to be solving rational equations. Alright, first thing, a rational equation is an equation that's made up of one or more rational expressions. Okay, we're going to be looking at time and hours that it takes to travel d miles. We're going to look at some word problems that involve this equation. Alright, and this equation just comes from the good old equation d equals RT, and we've just solved for t. Okay, to solve a rational equation, start by multiplying each term of the equation by the least common denominator. Alright, so this is our first step to find this. That step should eliminate the denominators and allow us to solve the equation. Okay, so here's our first example. What we need to do is find the LCD, which x is the only denominator, so x it is. Now the difference between an expression and an equation is that if this were an expression, first of all, there would be no equal sign, but we would have to multiply by x over x to everything. Alright, but since it's an equation, we don't have to do that. We can multiply by just x. We just need to make sure that we multiply every term by the same thing. So what we're going to do is multiply this one by x, multiply that one by x, and multiply that one by x. Alright, so we get x squared minus, these x's are going to cross out, so just 18 equals 3x. Now since our equation is quadratic, we need to get it set equal to 0. X squared minus 3x minus 18 equals 0. Now we need to factor. So we're thinking of two numbers that multiply to negative 18 that add to negative 3. So it's going to be minus 6 plus 3. So x equals 6 and x equals negative 3. Okay, now we need to glance back at the original. Is it okay to plug in 6 and negative 3? And it is. It looks like the only thing x cannot be is 0, which is okay with our answers. Alright, our next equation, we need to find the LCD, which is 3x. So what we need to do is multiply everything by 3x. Okay, so let's see, in the first one here, the 3's are going to cross out, so we get 10x equals, x is crossed out, so we get 12 plus 6x. Okay, this is linear, so we just need to subtract the 6x over here, and then divide by 4. Right, and then go back and check our denominator. Can we plug back 3 in for x? Okay, and I think we can. The only thing x cannot be here is 0, so our answer is okay. Alright, when we're solving rational equations, we may find extraneous solutions. So if you look at the first part of the word here, extra, it's an extra solution. Okay, it's one that does not fit with the original equation. Alright, so it's going to be important that we go back and check our answers and make sure that they work. Okay, here's our next problem. First thing we need to do, again, find the LCD. And in this case, it's x minus 2. Alright, so we're going to multiply each term by x minus 2. Alright, and very nicely they cross out. So we get 5x equals 3x plus 4. Linear again, so let's just subtract the 3x. We get 2x equals 4. Divide by 2, and x equals 2. Okay, so same thing that we've been doing. Let's go back and check our answer. But it looks like if we plug in 2 to the denominator, it's going to give us 0. Alright, so we cannot have that. So, no solution. Okay, our next one, find the LCD. Let's see, it looks like it's going to be 2 times x minus 8. So we're going to go through and multiply each term times 2 times x minus 8. Okay, so let's cross out the x minus 8's here and multiply by the 2. So 4x minus 10. Alright, the next one looks like the 2's cross out. So let's multiply here by the x. So we're going to get x squared minus 8x. Alright, the x minus 8's cross out here. 2 times 11 is 22. Alright, so we have a quadratic again, so we need to get everything on one side. X squared. Let's see, this is going to give us minus 4x. And then we have minus 10 equals 22. So we want to go ahead and subtract the 22. X squared minus 4x, let's see, that's going to give us minus 32 equals 0. And we can factor that into, it has to multiply to negative 32, but add to negative 4. So it looks like it has to be minus 8 plus 4. So x equals 8, x equals negative 4. Let's go back in and check. Okay, x minus 8 is in the bottom. So if we plugged in an 8 here, we would get 0. We know we don't want 0 in the denominator. Cross that one out. Negative 4 is our only answer. 8 would be an extraneous solution. Okay, that is extra. It is not correct. X equals negative 4, only answer. Okay, next we're going to look at some word problems. Take a second and read this. Okay, now the numbers here are going to be a little bit big, but it's okay. We have our calculators, so make sure they're out and ready to go. Alright, we're going to round our answer to the nearest mile per hour. Okay, so that's going to be the nearest whole number. Alright, so first we're just going to look at some important information. Make sure we understand the problem. Alright, so these would be things that we would underline in our paragraph if we were solving this. Okay, the jet spent 6.5 hours on the round trip. This is our total time. It went 3,950 miles east, 3,950 miles west. Its average speed with no wind is 485 miles per hour. Okay, all important information. Alright, next we're going to make a plan. Okay, W is going to represent the speed of the wind. Right. When the jet's going east, its speed is equal to the speed with no wind plus W. When it's going west, its speed is equal to its speed with no wind minus W. Alright, so our table here. The distance column, 3,950. Same for both, went the same both ways. Alright, then we have the average speed. Goes 485 miles on its own. When it's going east, the speed of the wind is increasing our speed of the plane. When it's going west, it's decreasing the speed because it's flying into the wind, so we have to put minus. Alright, now remember this is our d, r, and we said that time was equal to the distance over the rate, which is where we get our last column. Okay, so we want to set up the formula. The total time is equal to the time it took to go east plus the time it took to go west. From our important information, we knew that the total time was 16.5, so this is the equation that we need to solve. Okay, so in order to solve, we need to find the LCD, which is this. Okay, so we're going to have 16.5 times 485 plus W, 485 minus W equals, right? And then we have 3,950 over 485 plus W, and then we're going to multiply this by the LCD. Plus this times our LCD. Okay, so remember I said these numbers are getting a little bit big, but we have our calculators, so we'll be okay. Okay, so let's start on the left. Alright, nothing over here is going to cross out. So we have 16.5 times, okay, let's multiply these. This times this is 235,225. Okay, our middle terms are going to cross out. We have 1 plus 1 minus, and then we're going to get minus w squared. Equals, alright, let's see. Plus w's cross out here. So we have this times 485 minus w, plus, now the minus w's cross out, 3,950 times 485 plus w. Okay, so now we just have a lot of simplifying to do. First thing we're going to do is distribute the 16.5 and then distribute the 3,950 to each parenthesis here. Okay, so there's our 16.5 distributed. There's our first 3,950. And our second 3,950. Okay, so now we need to simplify. Alright, very nicely here we have 1 minus and 1 plus, so those cross out. So we have this side equal to, and we're going to add these two numbers together. And then solve for w squared. So this is our only variable. So what we want to do is get this one by itself. So we're going to subtract this from both sides. And we get negative 49,712.5. Okay, so we're going to divide by negative 16.5. And once we get that, we're going to square root our answer to get w. And we should get about 55 miles per hour. Okay, so like I said, numbers are pretty big, but we have our calculator, so we just need to keep it organized. We're going to look to make sure our answer makes sense. Okay, and it does. Our next example is very similar, but much smaller numbers. Okay, so we're going to find the average speed of the current of the river. We're going to round to the nearest tenth. That's 1 decimal place. Okay, so the first thing we want to do is understand the problem. Here's our important information. Kayaker spent 5 hours kayaking. This is our total time. Total time right here. She went 2 miles upstream, 2 miles downstream. Okay, so the same distance up, same distance down. Her average speed in still water is 2 miles per hour. Okay, so if there was no current at all, she can paddle 2 miles per hour. So let's set up our problem. Okay, let's let C represent the speed of the current. So if we have our distance table here, she went 2 miles upstream, 2 miles downstream. So if she's going upstream, she's going against the current. The current is going to make her speed slower. So her new speed would be 2 minus c. When she's going downstream, she's going with the current. The current's going to make her faster, so it's 2 plus c. And then remember, our time is distance over rate. Okay, so we know that her total time was 5 hours. So her total time is equal to the time upstream plus the time downstream. So now we just need to solve this rational equation. Okay, so the first thing we need to do is think of the LCD and then multiply each side by the LCD. Okay, so multiply it by the 5. And then multiply it by the right side. Okay, on the left side, nothing crosses out, so let's simplify. Let's multiply 2 minus c times 2 plus c, and we get 4 minus c squared times 5. Over here, the 2 minus c's are going to cross out. Alright, so we can see same setup, same process as the last problem. These numbers are a lot better to manage. So let's distribute the 5. 20 minus 5c squared equals 4 plus 2c plus 4 minus 2c. And let's simplify. Our 2c's can cross out. 4 plus 4 gives us 8. Okay, so let's subtract the 20. Alright, so again we're going to divide by the negative 5, and then we're going to take the square root, which will give us the speed of the current, and to the nearest tenth would be 1.5 miles per hour. Please make sure you're doing the steps in your calculator to make sure you're doing it correctly and can get the right answer. Okay, so let's check, make sure our answer makes sense with the problem. Okay, so if we calculate this, we're a little bit off. The total trip will take about 4.5 hours. But if you remember, we rounded to the nearest tenth, so it's going to make sense that our answer is a little bit off. Okay, but it's close enough to the given time of 5 hours, so we're good. Our answer makes sense. Okay, our next example. Take a second and read. Okay, whenever we have a problem here where we have people doing a job separately and then people doing a job together, what we need to do is find their rate. Alright, what's important to recognize is that the 500-piece puzzle doesn't matter. Don't get confused by the 500. Think of it as they are doing a puzzle. Actually, let's do this. Cross out the 5-piece. Okay, they're doing one puzzle. So if she takes 8 hours to finish the puzzle on her own, her rate is 1/8 of the puzzle per hour. Okay, so 1/8 per hour. If she does it for 8 hours, she'd be finished. Okay, next, Renzo's rate. They don't tell us Renzo's rate by himself. So we could say his rate is 1 over h. H is the number of hours needed to finish it by himself. Okay, our rates are always going to be set up in this fashion where you know how long it takes them to finish it, 1 over that time. Alright, so to figure this out, we take Natalie's rate times the hours worked, plus Renzo's rate times the hours worked, and it equals one complete puzzle. So this is really important, one complete puzzle. All right, Natalie's rate was 1/8. They worked for 4.5 hours plus Renzo's rate times the 4.5 hours equals 1 completed puzzle. All right, so what we need to do is figure out the LCD. And the LCD is 8H. So we're going to multiply everything by 8H. All right, let's see. The 8's going to cross out here. 4.5H plus. This H is going to cross out, so we need to do 8 times 4.5, which is 36, equals 8H. Okay, so let's subtract the 4.5H. We get 36 equals 3.5H. Divide by 3.5, and we get H equals 10.3 hours. Okay, next we have a similar problem. Julianne can mulch a garden in 20 minutes. Together with Remy, they can mulch the same garden in 11 minutes. How long will it take Remy to mulch the garden when working alone? So very similar problem as the puzzle problem. So what I'd like you guys to do is finish this one up on your own. Okay, use this formula here to solve, and then we will check our answer in class.